Hey guys, this is Dippy from SCADMC. I'm just going to quickly go over some basic insight into the OBJ wavefront to fastAsync world edit.schem pipeline. There's not that much data about it, so just like general insights in case you guys want to do it. Whether you're doing an entire city like Midtown Atlanta, or you're just doing your own room or something. Just some general tips for importing and how that pipeline is going to be made easier. So for the SCADMC server, we have a lot of 3D data samples, obviously, whether it's LiDAR that we've taken on our phones, or LiDAR from drones, or publicly available satellite data, or topography maps. You just want to have a really good 3D rendering. So I really can't help you with that first part. I can suggest that you hire out, find third-party programs or apps that will let you 3D scan a world or your environment. I think there's one on the App Store called Polycam that's pretty good, but I think you have to pay for it. Um, so this is that. This is a room in the Savannah College of Art and Design in Atlanta. This is a common room. This is the wire mesh frame of it. If you can see, this is a LiDAR. Or actually, sorry, this is something called I think this is a Gaussian splat, or it's photogrammetry. Either way, it's a collection of a bunch of photos, probably hundreds, of this room from all different angles, and it comes together to make this wire mesh. Now, we can kind of put a surface over that wire mesh to see what it looks like. You can see it's this room. You can see like it's very truly a thin wire mesh. You can see it's very thin at any given point. You can see that if there's indents on this wall back here, it's because something else is poking out in the front. Very, very self-explanatory. This is what our room looks like. Obviously, I've gone through this already. If you're taking an OBJ, or if you have your data set, whatever it is, and you put it into a 3D rendering program like Blender, you're going to want to triangulate it. Most programs will do this as like a form of compression. Obviously, you just want to do it before we get to the Minecraft step because you can see where all of our data is concentrated and where it kind of sparses out. A lot of these 3D data sets that you might have or that you might collect, whether from LiDAR or photogrammetry or Gaussian splats, aren't perfect. So you need to remove any n-gons. N-gons being any polygon that has four or more sides. Triangles are really easy to compute and save a lot of storage and are essential for this Minecraft pipeline to work. So once you triangulate everything, if you're going to triangulate anything, by the way, in Blender, it's a really simple modifier. Just select your container that you want, add modifier, generate, and then triangulate right down there. If you did not know, so we have triangulated our space. We can see all the forms. These are some seats, some little tables in the walls. This is what it looks like. And you want to have this wire mesh, and you want to have it triangulated. There are textures associated with this due to how we exported it. Truly, in an OBJ pipeline, you need to export kind of like PNGs of the textures if you wanted them, or bake them in. Not really something you can do in Minecraft, but if you do it beforehand in a different program, we can kind of export it as a GLB or a GLTF 2.0, which is this bottom one down here, as opposed to an OBJ, because it's gonna basically bring the textures and have it mapped out already for us when we're bringing it to a different renderer or viewport online for like the OBJ.schematic. So this is what the wireframe is going to look like whenever you finish it. You can put different data sets together. You can use just one capture program, really quick and dirty if you just want to record and like put a pair of shoes into Minecraft. Doesn't really matter, but for larger spaces like Atlanta, definitely the more data you have, the better, and you can kind of pick and choose and combine it in these kind of programs to make the best version of whatever you want to put into Minecraft. This is just a quick and dirty. You can see this kind of, if you look right here, the photogrammetry kind of messes up. It doesn't really know where to put walls and stuff because it's basically just compiling a bunch of photos together to try and make a bunch of polygons. So we can see that definitely screws up these end pieces, especially like the windows. So this is it. This is basically all you're going to do. You're going to export it as a GLB. You're going to want to go to OBJ to schematic. That's the easiest viewport renderer you can use. It runs fully in Chrome. You shouldn't need any extra RAM. And then in there, in that obj.schem, you can choose like the dithering magnitude, which is basically like how many pixels or I guess voxels appear in comparison to like their pixel counterpart. So basically, that online obj.schematic program is going to voxelize your entire piece, and it's also going to have the fun feature since it's being built for .schems and essentially like Lightmatica and FastAsync World that it is that you can assign textures to it. Minecraft textures is pretty up to date. That's going to be really key and essential. It's a fantastic program. And once you have that, you can export as Lightmatica or like a FastAsync World Edit like we talked about, and then you'll get to Minecraft, and you can see that this is what it's kind of going to look like. You can see we have all these wonky parts sticking out of it. It's kind of like 2D pixel art, but it's trying to put it over a 3D spread of polygons. So if we look here, we can see it's really just a mesh. Everything's really just like one block thick, and then we get into the thick of it, not by KSI. So if we come in here like through this door, these glitches, you can see this is generally what we were just looking at. This is generally the couches and the seats. This is what the second floor of one of the SCAD buildings looks like as a common room. So you can see that it's basically the same. You can see the dithering magnitude. There's like this weird artifacting that appears, weird color distortion. You can all fix that. That obj.schem program is so customizable. It's fantastic. Use it for everything. Obviously, this wouldn't work for SCADMC because if here I'll show you like the courtyard. A big part of SCADMC is recreating all of these spaces in Minecraft, and you can use this technique for cities, sure, and for other things. I mean, probably not only this 3D data set for cities, but for smaller objects, if you want to put like a small room or an object into Minecraft, it's definitely the way to do it. But for the courtyard, you'll see that photogrammetry and skies and bigger 3D spaces don't work well at all. And it's really impossible. So I'm just going to illustrate that with you. This is the courtyard from the SCAD Atlanta campus. As you can see, this is the kind of the 40 building. This is the sky. And you can see the screen back here has completely been oriented at a different angle than where it actually is due to some artifacting and some corruption in the data set. And you can see what palette was supposed to be. You can see all the facilities generally. But you can see how it's still a wire mesh, but it's being compressed from the photogrammetry or Gaussian splats. This wasn't LiDAR. Obviously, LiDAR can't go up that high. I mean, not as high as like a 14-story building. Like it would need to be at a minimum for the SCAD courtyard. So this doesn't really work with cities, which this is just like the stepping blocks and like the base blocks of getting you to think about how we can kind of do this 3D model pipeline into Minecraft. So this isn't what we use specifically, but it's a good way to start thinking about it and visualizing, oh, there's things that we can do to put blocks into the game without manually placing every single one. If you want to know kind of how it turned out, like what other processes we used or proceeds or whatever, this is, you're looking around, this is closer to what we ended up using. This is a first dry run at publicly available satellite data being mapped out over a wireframe of some basic buildings. I think this is exclusively just publicly available data. It's not any of our other data sets or recordings, and you can see it's really wonky. You can see it doesn't really connect to the ground. The terrain, topography really doesn't match well. And even buildings aren't the proper size. Like this is not how tall this is. This is a 14-story building. This is the courtyard we're just looking at. And you can see everything's not to scale. So it's definitely a start. This is just like the publicly available satellite data. And then, of course, we start getting into the putting all of our 3D sources together. This isn't it. This is just a step closer to it. You can see it's kind of maybe a little bit bigger. Everything's more to scale, but there's still some weird floating aspects to it because it's not our final version yet. The final version is the next one. We kind of just line them all up right next to each other, just so I could easily see everything. So the next version I think is probably one of the final ones. Yeah, this is the final combo of most of our data set. So you can see there's the dithering magnitude. You can see this pixelation artifacting some of the ground pieces, and you can see some of that incorporation of the publicly available OSM satellite data. But there's no like Google Maps texture kind of like put onto it yet. There's no like drone data being put onto it. You can kind of see the courtyard. Everything touches the ground now. I mean, mostly everything. I guess that doesn't. But essentially everything else touches the ground that wasn't touching the ground before. It's the main part of it. See, everything like the proper size and what it's supposed to be. Big improvement. So you're slowly just adding more and more 3D data sample sets or 3D renderings or LiDAR data on top of each other progressively to build it up. So we basically ended with this. This is basically what I was using the Atlantic Station over there. This is basically what we ended with before draping textures onto it. So this is all pretty much textureless. It's basically looking at like the wireframe with like that white surface covering it. They're looking at the viewport shading in the Blender, but just in Minecraft. And when you put all the textures over it from like drones and satellite data and a bunch of other stuff, then you get that kind of weird, you get kind of like the weird like finished result like this. Like this is basically the finished result. You can see it follows the pattern of everything still, but you can see there's foliage that's been added. That's probably most important. The foliage has been added. Everything's been expanded to its true size with the 3D data because it's just following the other stuff as like a roadmap. And you can see it's all the same, but you can still see like some dithering magnitude, like dithering, whatever. You can see the pixel artifacting. That's all I'm trying to say. So you can see how the different processes. You can essentially see how we kind of layered it up, how we took like one layer of data and put on another one, etc., etc. So we built it up all the way. So this is what it looks like. This is the finished area. Obviously, probably some more attention needs to be done closer to the ground, and probably filling out some spaces and some more finer detail like the courtyard has when we get to that. But for the most part, this is basically it. So again, that's kind of the pipeline that we used for kind of modeling the 3D world, and for kind of doing like the OBJ GLB pipeline into Minecraft. It wasn't really popularized until like a few years ago. It's always been like a technique of like trying to illegally rip Google Maps data. Obviously, you can't you have to like pay Google like a key and get like an API to even like touch any of their 3D data. So it's like, how do you go about not using the most popular data set in the world because it's like pay for it or whatever? And this is what you end up with. So it's an OBJ, it's taking 3D models and a combination of 3D objects and buildings that we put together in Blender and cohesively making them into Minecraft. So thank you so much.